Have you ever stopped and wondered why a woodpecker keeps hammering at trees all day long? Is it restless? Is it aggressive? Is it simply obsessed with wood? The truth is far more fascinating. The woodpecker does not drill into trees because it is wild or reckless. It does it to survive, to communicate, to build, and sometimes even to impress. Behind every rapid tap is a masterpiece of biological engineering designed by nature itself. A woodpecker drills into trees for three main reasons: to find food, to create a nesting cavity, and to signal its presence to rivals or potential mates. Inside tree bark live insects, larvae, and ants, a rich protein source. By drilling into the trunk, the bird can extract these hidden meals. But beyond feeding, the woodpecker also carves out precise cavities to build its home. These hollowed chambers become safe nesting sites, protecting eggs and chicks from predators and harsh weather. And then there is drumming, a rapid-fire tapping sound that echoes through forests. This is not random noise, it is a communication signal. A woodpecker drums to declare territory and attract a partner. Now, here comes the astonishing part. A woodpecker can strike a tree up to 20 times per second. Think about that for a moment. 20 impacts every single second. The force of each strike can be compared to the impact of colliding with a fast-moving vehicle. If a human were subjected to that kind of repeated force, even once, it could result in a serious concussion or brain injury. Yet the woodpecker remains completely unharmed. How is that possible? The answer lies in one of nature's most brilliant structural designs. First, consider the skull. A woodpecker's skull is thicker and stronger than that of most birds. But strength alone is not the secret. Inside the skull, the bone has a unique spongy structure. This sponge-like material acts as a shock absorber. When the bird strikes a tree, the impact energy is partially absorbed and distributed throughout the skull, preventing direct trauma to the brain. Second, the beak plays a crucial role. The upper and lower parts of the beak are not exactly the same length. There is a slight difference between them. This tiny variation helps distribute the impact force more evenly. Instead of concentrating all the shock in one place, the energy spreads out, reducing the risk of damage. But the most extraordinary feature is hidden inside the head: the woodpecker's tongue. Unlike most birds, the woodpecker has an incredibly long tongue. It is not just used to extract insects from deep inside tree bark. The tongue wraps around the skull from the inside. It extends backward, loops over the top of the skull, and sometimes even encircles it completely before anchoring near the nostrils. Imagine wearing a helmet with an internal safety strap wrapped tightly around your head. That's exactly how the woodpecker's tongue functions. When the bird strikes a tree, this wrapped tongue acts like an additional safety harness. It stabilizes the brain and absorbs part of the shock, protecting delicate tissues from sudden deceleration. There's more. The brain of the woodpecker fits very snugly inside its skull. There is very little empty space. In humans, the brain has room to move slightly inside the skull. During a sudden impact, that movement can cause concussions. In woodpeckers, the tight fit minimizes movement. Less movement means less internal damage. Additionally, woodpeckers strike at a precise angle. They do not hit the tree randomly. The force is directed in a straight line, reducing rotational movement. Rotational forces are especially dangerous for brains as they cause twisting injuries. By maintaining perfect alignment, the woodpecker reduces harmful stress. Even the neck muscles are highly specialized. They are strong enough to control rapid forward motion while also stabilizing the head during impact. This coordination ensures that each strike is controlled, not chaotic.
All these features together create a natural shock-proof system. Skull structure, spongy bone, asymmetrical beak, wrapped tongue, tight brain fit, precise angle, and strong neck muscles, each element plays a role. None of them alone would be enough, but combined, they form a biological masterpiece. Scientists and engineers have studied woodpeckers to design better helmets, protective gear, and shock-absorbing materials. The bird's head structure has inspired innovations in sports safety equipment and even aerospace engineering. Nature solved a problem millions of years ago that humans are still trying to perfect. Beyond physics, there's also rhythm and intelligence in its behavior. Woodpeckers choose specific trees depending on sound quality. For communication, they often drum on hollow surfaces that amplify the sound. It's not just strength, it's strategy. There are over 200 species of woodpeckers around the world, living in forests, grasslands, and even deserts. Some are small and delicate, others are large and powerful. Yet they all share this extraordinary impact-resistant design. Interestingly, woodpeckers also have special eyelids that close milliseconds before impact. This protects their eyes from flying wood chips and debris. Their nostrils are covered with tiny feathers to prevent dust from entering while drilling. Every detail has a purpose. When we compare this to humans, the contrast is striking. A single strong head impact can cause dizziness, memory loss, or unconsciousness. Repeated impacts can lead to long-term brain damage. Athletes wear helmets, soldiers use advanced protective gear, and vehicles are equipped with airbags. Yet a small bird in the forest performs high-speed impacts thousands of times a day without injury. This is not luck, it's evolution. Over millions of years, natural selection refined the woodpecker's body. Birds that could not withstand the impact simply did not survive. Gradually, the perfect combination of structure and function emerged. And perhaps that's the most powerful lesson here. Nature is not random chaos, it is an engineer. It tests, adjusts, improves, and perfects through time. The next time you hear the rhythmic tapping of a woodpecker echoing through trees, don't think of it as noise. Think of it as a demonstration of advanced biological engineering in action. Each tap represents survival, adaptation, and design. Where a human head might fail after one collision, the woodpecker performs thousands with precision and resilience. That's not just a bird. That's nature's shock-proof machine.